Hello again. This is section 7.3, double angle, half angle, and product sum formulas. And so we're going to look at some more identities in this section, specifically dealing with how do we take things that might involve double angles, half angles, and then at the end we'll look at what we call the product sum formulas, where we take a product, we convert it to a sum, or vice versa. All right, so we're going to start with our double angle formulas. So notice here, double angle meaning 2 times some angle. So the sine of 2x is going to be equal to 2 sine x times cosine x. So we can rewrite any of these double angles now in terms of these other formulas. Now notice here with the cosine of 2x, we have 3 different options. All 3 of them will give you the same result, but in some cases, one of them might be easier to use depending on the problem that we're working on, right? And so I'll try to point out as we go through what tells me which of those 3 formulas I might want to use. And then with tangent of 2x, again, we only have one formula for that. And so we get 2 tangent x over 1 minus tangent squared x. All right, so our first example, we've got cosine x is negative 2/3. We know that x is in quadrant 2, and we're asked to find the cosine of 2x and the sine of 2x. So I'm going to start with cosine of 2x. All right, and I know the information that's given this time is that cosine x is equal to negative 2/3. Now, because of that, that tells me that I want to use the double angle formula for cosine that involves a cosine, right? And the one that we're going to use then is going to be 2 cosine squared x minus 1. Now, again, I could have used any of the 3 because they'll all give me the same answer, but because I'm given cosine this time, it probably makes the most sense to use the formula that has a cosine in it. All right, so now we can substitute. So I'm going to have 2 times, in place of cosine, I'm going to put negative 2/3. That gets squared, and then we're going to subtract 1. And we'll follow our order of operations to simplify. So the first thing we do is the exponent. So negative 2/3 squared should give us 4 over 9. Now we can multiply. 2 times 4 over 9 should give us 8 over 9. And when we subtract here, we're going to need a common denominator. So we have 8 over 9 minus 9 over 9. And when we do that, that should give us negative 1/9. All right, now let's look at sine of 2x. Now with sine, we only have one option for that formula, right? So that one is 2 sine x cosine x. Well, in this case, that means I need to find sine because I only know cosine here. So the way I'm going to do this, I'm actually going to draw a triangle that's going to help us to figure out what the sine value is going to be. So I'm going to start here, draw my triangle. I'm going to label my angle as x. And since we know cosine is negative 2/3, that gives me the adjacent and the hypotenuse. So I'm going to use 2 and 3. And I'm just going to keep this positive because we already know we're in quadrant 2, and so we'll take care of the signs of everything once we actually start substituting in. Now I can use Pythagorean theorem to find my missing side. So that's going to be 2 squared plus b squared equals 3 squared. Well, 2 squared is 4. 3 squared is 9. If I subtract, I get b squared is equal to 5. And taking the square root, b is equal to square root of 5. So I know this side over here is going to be square root of 5. Right, now I should have everything I need to substitute. So we're going to get 2 times. Now I need sine of x. So sine is going to be opposite over hypotenuse, which is going to be square root of 5 over 3. And notice here we're in quadrant 2, and in quadrant 2, sine should be positive. So we're going to leave that as a positive square root of 5 over 3. Now we need to multiply that by cosine. Okay, cosine was actually given here as negative 2/3. We could have also gotten it from our triangle at the bottom. And just make sure, because we're in quadrant 2, we make that a negative value. And now we just have to multiply. So we're just going to multiply straight across. 2 times square root of 5 times negative 2 is going to give us negative 4 square root of 5. And if I multiply by denominators, 3 times 3 is 9. So our sine of 2x is negative 4 square root of 5 over 9. All right, right, now our next example says we want to write cosine of 3x in terms of cosine x. Now, we don't have a triple angle formula, right? We only have a double angle formula. So the first thing we're going to have to do here is rewrite that 3x in terms of something that we can actually work with. So I'm going to change the cosine of 3x to the cosine of 2x plus x, because we know that 2x plus x would give us 3x, and we have formulas to deal with that addition, and we have a formula to deal with the double angle now. So I'm going to start by rewriting this with my addition formula back in section 7.2. So this is going to give us cosine 2x times cosine of x minus sine of 2x times the sine of x. Now from here, I'm going to start using those double angle formulas to try to get this down in terms of just a cosine of x. So cosine of 2x, since I'm trying to get everything in terms of cosine x, I'm going to use the one that's in terms of cosine again. So that's going to give us 2 cosine squared x minus 1 times cosine x. Sine of 2x, I only have one option. That's 2 sine x cosine x. And then I still need to multiply by sine x. So again, I've just changed my cosine of 2x to 2 cosine squared x minus 1, changed the sine of 2x to 2 sine x cosine x. Now let's go ahead and multiply out what we can, and then we'll figure out what to do from there, because we still have some sines in here. We need everything in terms of cosine. So if I distribute this cosine x, it's going to give us 2 cosine cubed x, and then cosine times a negative 1 is minus cosine. Now down here, this is all just being multiplied together. So this is just going to be 2 sine squared x cosine x. Okay, so all we need to do now is try to get that sine squared in terms of a cosine, and then we should have everything in terms of cosine. Well, if you recall, one of our Pythagorean identities is sine squared plus cosine squared is equal to 1. So if I move my cosine over, sine squared x is equal to 1 minus cosine squared x. So in place of sine squared, I can put 1 minus cosine squared. So that's going to give us 2 cosine cubed x minus cosine x minus 2 times, and in place of that sine squared, we get 1 minus cosine squared x times cosine x. Now at this point, everything is in terms of a cosine x. I just want to clean it up a little bit, so I'm going to distribute, see if we have any like terms that can combine. So we'll keep the 2 cosine cubed x minus cosine x. Multiplying this out down here now, we get minus 2 cosine x. And then a negative and a negative gives us a positive 2 cosine, and then cosine squared times cosine is going to be cosine cubed x. Now I notice I've got some cosine cubes that I can combine. I also have some cosine x's I can combine, so let's put those together. 2 cosine cubed and 2 cosine cubed is 4 cosine cubed x. And if I combine the cosines, that's going to give us a minus 3 cosine x. And that is our final answer now. We've gotten everything in terms of just cosine x. We got rid of that triple angle. All right, so number 3, we want to prove this identity. So again, we're trying to show that the left-hand side and right-hand side are equivalent to each other. Now, first thing I notice here is that I've got a triple angle in my numerator on one side. It's probably going to be easiest to work with that and see if we can make the left-hand side look like the right-hand side, because it's going to be a lot more difficult to get the right-hand side in terms of that triple angle. So we're going to do similar work to what we did on the previous problem. We're going to take that sine of 3x. I'm going to rewrite it as the sine of 2x plus x. Okay. And that's still over sine x cosine x. All right, now at that point, I'm going to use my addition formula for sine, which is going to give us sine 2x cosine x plus cosine 2x sine x. All of that is still over sine x cosine x. Okay. Now, at this point, we have to decide which way we want to go, right? Because we've got a sine of 2x. We know for sure what that's going to be equal to. We can do 2 sine x cosine x for that. And then that gets multiplied by cosine x. But this cosine of 2x, we have some options, right? And so we just need to decide which one we want to use. I'm looking at the right-hand side, and I notice that everything's in terms of cosine and secant. Well, secant's just the reciprocal of cosine, so I'm probably going to want most things in terms of cosine here, right? So I'm going to use that same cosine formula for my double angle. So 2 cosine squared x minus 1, and then times sine x. Again, kind of use your clues in the problem to decide which of your double angle formulas you might want to use for the cosine. All right, now from here, let's go ahead and clean this up a little bit, and then we'll kind of figure out what we might be able to simplify. So if I multiply what we have in that first term, that's going to give us 2 sine x cosine squared x. Distributing over here now, the sine of x, I get plus 2 sine x cosine squared x, and then minus sine x. All right, now what I notice is in the numerator, all of my terms have a sine of x in common. And so basically, I can factor out that sine of x and cancel it with the one in the denominator. So at this point, all of these sines we can just get rid of. I also see that I have a couple of cosine squared terms, and I can combine those now. So that's going to give us 4 cosine squared x. And then down here, because that term canceled out, that's just going to be a minus 1. And all of that is over cosine x. And at this point, we can actually divide both of our terms by cosine, which is going to give us 4 cosine x minus 1 over cosine x. And we know that 1 over cosine is just secant, and so we get 4 cosine x minus secant x, which is exactly what we wanted on the right-hand side. And so we've shown that the left-hand side is indeed equal to the right-hand side here. All right, now we also have formulas for lowering powers. So if you're ever given a sine squared, cosine squared, tangent squared, and you need to get rid of the square, we can actually use these formulas to do that. So sine squared is just 1 minus cosine 2x over 2. Notice the cosine squared, very similar. The only difference is there's an addition in that numerator now. And then our tangent squared is 1 minus cosine 2x over 1 plus cosine 2x. All right, so I'm going to express sine squared x, cosine squared x in terms of the first power of cosine. So we're just trying to get everything in terms of a cosine to the first power here. So I'm going to use those lowering power formulas that we just saw. And so this sine squared is just going to become 1 minus cosine 2x over 2. And the cosine squared becomes 1 plus cosine 2x over 2. Now you might be thinking, well, we're done, right? The only problem here is if I were to actually keep all this and multiply it together, I'm still going to end up with a cosine squared. And so I'm going to go ahead and simplify this, multiply it out so that we can see that we get a cosine squared, because we're still going to want to simplify that and get it down to a first power of cosine. So I'm going to distribute all this out. So notice here I basically have a binomial in my numerator times a binomial over here. 1 times 1 is 1. My outer and inner terms here are opposites. They're going to cancel out. And then we have a negative cosine 2x and a positive cosine 2x. So that's minus cosine squared 2x. And then if I multiply my denominators together, 2 times 2 is just going to give us 4. All right, now, just so I don't have to deal with a fraction within a fraction, I'm going to split this up and write this as 1/4 minus 1/4 cosine squared of 2x. Right? So instead of having cosine squared 2x over 4, since I know that squared formula is going to give us a fraction, I'm just going to go ahead and put the 1/4 out front. Now I'm going to use my lowering powers formula again. So we're going to get 1/4 minus 1/4 times, and in place of this cosine squared, I'm using that same formula we did up top. We're going to get 1 plus cosine of, now here's where we have to be careful. Since we already have a 2x inside here, we still need to multiply that by 2, because that's what our formula has in it, right? And so this is going to be 2 times 2x, and then all over 2. And so now if we simplify all of this, we get 1/4 minus, now up top, we're just going to have 1 plus cosine of 4x. On the bottom now, we can multiply the 4 and the 2 together, and that's just going to give us 8. And honestly, we can leave our answer just like that if you want to. If you wanted to find a common denominator and put these together, you could also do that. I'm not too picky about what I would accept if I gave you a question like this on a test or exam. So just know once we get it down to just a cosine to the first power, now we're fine. Okay, but do not stop at that very first step, because technically there's still that cosine squared within that answer there. All right, now half angle formulas. If we have the sine of u over 2, we can write that as plus or minus square root 1 minus cosine u over 2. And the plus or minus is going to be determined by which quadrant u over 2 is in. Okay, so we're not looking at the u value, but whatever u over 2, the original angle, whatever that is, that's what's going to determine the plus or minus. Okay, now cosine of u over 2, very similar. Again, the only difference is we have a plus in the numerator there. And then we have 2 options for our tangent of u over 2. Both of them, again, will give you exactly the same answer, so it does not matter which one you use. All right, so let's see if we can find an exact value now for the sine of 22.5 degrees. Now, obviously 22.5 degrees, not one of our special angles, not on the unit circle. So what we're going to have to do here is think about, is there an angle that we're familiar with that we could cut in half to give us 22.5 degrees? And that angle is going to be 45 degrees this time. So I'm going to rewrite this as the sine of 45 divided by 2. Now, remember our formula for sine of a half angle is going to give us plus or minus the square root 1 minus cosine of the u value, which in this case is 45 degrees, divided by 2. So now we need to simplify this. Before I do that, let's talk about whether we're going to have a plus or a minus here. Since the original angle, 22.5 degrees, is in the first quadrant, we're evaluating sine. Sine in the first quadrant is going to be positive, so we're going to take the positive. And again, we're always basing it off of the original angle, the 22.5, not the 45 here. Even though technically they would both give us the same answer, that's not always going to be the case. Sometimes that u value would be in a different quadrant. We always base it off the u over 2, the original angle. Okay, so now, keep it positive. We're going to have 1 minus. Cosine of 45 degrees, we know, is square root of 2 over 2. And all of that is over 2 now. Now I need to simplify this. I'm going to use a common denominator. So 1 becomes 2 over 2 minus square root of 2 over 2, all over 2. Putting that together, we get 2 minus the square root of 2 over 2, all over 2. And remember, when we have a fraction and we're dividing, we're really just multiplying by the reciprocal. So I'm going to think of this as 2 over 1 in my denominator. So we end up with 2 minus square root of 2 over 2 times 1 over 2. And that's going to give us the square root. 2 minus square root of 2 over 4. And because we have a perfect square in the denominator, we can go ahead and take the square root of that. So we're just going to get square root 2 minus square root of 2 over 2. And that would be our exact value for the sine of 22.5 degrees now. All right, now this time we're looking for the tangent of u over 2, and they just tell us that sine of u is 2/5 and that u has to be in quadrant 2. Now we know our tangent of u over 2 formula. Again, we can use either of them. It doesn't matter. They're going to give us the same answer. I'm just going to go with the first one, 1 minus cosine u over sine u. Now, we're given sine of u, so we have that information, but we don't know cosine. So we're going to have to somehow find it. Now, it's up to you. We can draw a triangle to find cosine. We can use identities to find cosine. I'm going to go with identities here, because we know that sine squared plus cosine squared is going to be equal to 1. And so if I plug in my sine, we're going to get 2/5 squared plus cosine squared equals 1. Squaring 2/5, we get 4 over 25. And now I need to subtract. So we're going to get cosine squared. We need a common denominator here, so that's going to be 25 over 25 minus 4 over 25. So cosine squared is 21 over 25. And now we take the square root of both sides. And that's going to give us the square root of 21 over square root of 25 is just 5. Now, don't forget, technically there's a plus or minus here because of that square root. And because we're in quadrant 2, the u value itself is in quadrant 2. That tells us that cosine of u has to be a negative value. So we want to make sure we take the negative for that. All right, now we have all the pieces. Now we can just substitute in. So over here, we're going to get 1 minus our cosine value that we just saw. So that's going to be negative square root 21 over 5. And we're going to put that over the sine, which is 2/5. Now, subtracting a negative, we actually add there, right? And I need a common denominator. So this is going to be 5/5 plus square root 21 over 5, all divided by 2/5. putting that together, we get 5 plus the square root of 21 over 5 divided by 2/5. And since we're dividing fractions, we're going to multiply by our reciprocal. 5 plus square root of 21 over 5 times 5 over 2. The 5's cancel, and we're left with 5 plus square root of 21 all over 2. And so there is our simplified answer. That is the value for tangent of u over 2 now. So again, whenever you're looking for these half angles and you're not given the specific value for the angle itself, just think about your formula, think about what information you need, use the information that's given to help you find any missing information for that formula. Always pay attention to your quadrant so you make sure your signs are correct. Right? And then once we substitute everything in, then it's just a matter of simplifying from there. All right, so now we want to write the sine of 2 inverse cosine x as an algebraic expression in terms of x. Again, they're telling us here that x has to be between -1 and 1, just so our domain is correct for that inverse trig function. All right, now this is similar to something we just did in the previous section. This time, though, instead of having addition or subtraction inside of our sine function, we have a single inverse trig function, but it's multiplied by 2. So I'm going to start here by saying, well, let's let theta be equal to our inverse trig function. So theta equals inverse cosine x, which means that cosine theta is equal to x. And so I can rewrite my original function as the sine of 2 times theta. Well, we know sine of 2 theta is going to give us 2 sine theta cosine, our double angle formula. And so now I need to know sine theta and cosine theta. Well, we know cosine theta, right? We just showed that that's going to be equal to x. And so to find the sine of theta, I have a couple of options. I can use identities. I can use triangles. I'm going to go with a triangle this time, just to show you that we have options here. I'm going to put my theta down here. Remember, if we're given cosine, that tells us the adjacent over the hypotenuse. So the adjacent is going to be x. The hypotenuse is going to be 1. And now we can use Pythagorean theorem to find our missing side. So x squared plus b squared equals 1 squared. Moving the x over, we get b squared equals 1 minus x squared. And now we take the square root of both sides. So we get square root of 1 minus x squared. And on problems like this, we'll never have to worry about our quadrant or anything. So always just assume it's going to be a positive square root, not a plus or minus. So now we know this side over here, square root 1 minus x squared. And now we should have everything we need to substitute. So we're going to have 2 times. Our sine of theta is going to be the opposite over the hypotenuse. So that's square root 1 minus x squared over 1. Our cosine is adjacent over hypotenuse, which is just x over 1. And now if we multiply all that out, we get 2x times the square root of 1 minus x squared. And so this right here is our final answer. There's our expression in terms of x only, and we got rid of that inverse trig function. All right, so now we have a similar problem, except this time we actually have a value for our cosine instead of having x's in there. So we're trying to find the sine of 2 theta if cosine theta is -2/5 and theta is in quadrant 2. So again, I'm going to start by just rewriting the sine of 2 theta as 2 sine theta cosine theta. Again, we know the cosine, but we don't know the sine, so I need to find sine somehow. This time I'll use identities just to show you how we can do that instead. So sine squared theta plus cosine squared theta is equal to 1. I'm going to substitute my negative 2/5 in place of the cosine. So we get sine squared theta plus negative 2/5 squared equals 1. Now we square negative 2/5. Sine squared plus 4/25 equals 1. Again, I need to subtract that now, so that's going to give us 25/25 minus 4/25. Sine squared then is 21/25. And when we take the square root, that's going to give us square root of 21/5. Pay attention to our quadrant here. We're in quadrant 2, but that means that sine is going to be positive, so we don't need to worry about the negative here. All right, now we have all of our pieces. Now we can substitute in. So we get 2 times, in place of sine, we have square root 21/5. In place of cosine, we have negative 2/5. And if we multiply this out now, we're going to get negative 4 square root of 21 all over 25. Again, we could have used a triangle, a right triangle for this one. Use your adjacent is 2, your hypotenuse is 5. Pythagorean theorem will give us the opposite side, and then with that opposite side, we could find the square root of 21/5 for our sine value. Okay, so either way is perfectly fine. I just want you to be familiar with both because some people do prefer that algebraic way of thinking. Other people like the geometric way with the triangles. I do not care on a test or exam which one you use. All right, and then our product to sum formulas. So notice here we've got some products, sine of u times cosine of v, cosine of u times sine of v, and so on. We can actually rewrite those products in terms of a sum now. So notice here we've got 1/2 sine of u plus v plus the sine of u minus v. And all of these formulas look very similar, right? Just with changes in where the addition subtraction is, or in terms of where the cosine or sine are. Now, all of these identities, again, will be given to you, right? So you don't need to worry about memorizing any of these. It's just a matter of recognizing when to apply each one. All right, so we want to take sine of 3x, sine of 5x, and express it as a sum of trig functions now. So we're looking at our sine, right? And notice here it's a sine times a sine, which is the last formula on that list that we just looked at. And so I know that this is going to give us 1/2 cosine u minus v minus cosine u plus v. And here our u value is going to be the 3x, and the v value is going to be the 5x. So now it's just a matter of substituting that in. So we're going to get 1/2 cosine 3x minus 5x minus cosine 3x plus 5x. Now we can simplify what's in our parentheses. So we get 1/2 cosine of negative 2x minus cosine of 8x. Now, the only thing I might do at this point is because we have a negative inside one of these, I could use my even odd properties to get rid of that negative inside the cosine. If you recall, because cosine is an even function, the cosine of negative 2x is equivalent to cosine of 2x. So I can actually just write this as cosine 2x minus cosine 8x now. And that's all there is to that one. So again, just identify which formula are you using, figure out what your u and v values are, and then just make sure you're carefully substituting those in. And again, if you ever get negatives inside one of your trig functions, use your even odd properties to help simplify that. All right, and then we have what's called the sum to product formula. So if we're adding or subtracting two trig functions, sine plus sine, sine minus sine, or cosine plus cosine, cosine minus cosine, we can actually change those now to these product formulas instead. And again, you'll see there's a lot of similarity between each one. Just be careful with any negative signs, whether you're adding or subtracting, and whether you're dealing with sine or cosine in each case. All right, so we want to write sine of 7x plus sine of 3x as a product instead. All right, so we have a sine plus a sine. That's the very first formula on that last slide. So we need to figure out what our x and y values are. In this case, the 7x is like the x in our formula, and the 3x is like the y. So we know when we're doing this, we're going to get 2 sine x plus y over 2 times cosine x minus y over 2. Now we just substitute, so we get 2 sine. Our x becomes 7x. Our y becomes 3x all over 2. And then cosine I apologize for that technical difficulty. So I'm going to continue on here. So again, remember we're using our formula here that says that this is going to be equal to 2 sine x plus y over 2 cosine x plus x minus y over 2. All right, so substituting in now, our x value we just said a minute ago is going to be 7x, plus our y value is going to be 3x. And then we have the cosine of 7x minus 3x all over 2. And so now we can simplify that. 7x plus 3x is 10x, and 10x divided by 2 should give us 5x. Cosine of 7x minus 3x should give us 4x. 4x divided by 2 is going to be 2x. And we're done. Okay, so 2 sine of 5x, cosine of 2x. We don't have any negatives in there, nothing else to simplify. That is our answer. All right, and our final example for this section, we're trying to verify this identity. So again, trying to show that the left-hand side and right-hand side are equivalent to each other. Now, in this case, right, it makes the most sense to work with the left-hand side. It's going to be a lot easier to simplify that down to a tangent than to work with tangent and try to get what we have on the left. Now, what I notice is I actually have one of those sum to product forms, right, on the left-hand side in both the numerator and denominator. So I'm going to use those formulas now to help us simplify this down. So since I have a subtraction in my numerator and they're both sine, that formula is going to give us 2 cosine. And then we're going to have x plus y, which in this case is 3x plus x divided by 2. And then we're going to multiply that by sine of x minus y, which is going to be 3x minus x over 2. Okay. Now in the denominator, since we have a cosine plus a cosine, we're going to use that third formula from that slide. And so that's going to give us 2 cosine x plus y, so 3x plus x over 2. And then we're going to multiply that by cosine, and we're going to subtract 3x minus x over 2. So again, I'm just using the sum to product formulas here. In the numerator, we have the difference of 2 sines. In the denominator, we have the cosine sum formula. And so now if we simplify this, that's going to give us 2 cosine. 3x plus x is 4x, divided by 2 is 2x. Then we have sine of 3x minus x is going to be 2x divided by 2 is just x. On the bottom now we have 2 cosine of 3x plus x is 4x, divided by 2 is 2x. And then we have our cosine of 3x minus x is 2x. 2x divided by 2 is x. Now notice here we have a 2 cosine of 2x in the numerator and denominator. I can actually cancel out those factors. That leaves us with sine over cosine, and we know that sine over cosine is tangent x. That's exactly what we wanted on the right-hand side, and so we're done. All right, so like I said, that's all we have for section 7.3. That should give you all the information you need now to complete that homework assignment for 7.1 through 7.3. Please let me know if you have any questions as you're working through that, and I will see you next time.